Welcome to Alpha Online Education YouTube channel. Please subscribe for more videos. In earlier class, we discussed about what is more rest and motion and types of motion means rectilinear or translatory motion and rotatory or circular motion and as well as oscillatory motion we have discussed. And also both that motion means if the body is moving along a straight line, then what is the motion? The way of motion means when the body is moving along a straight line in any coordinate axis, maybe any coordinate axis, then if the body is moving along x axis or along y axis or along z axis, is considered as a one-dimensional motion, that is also called as a rectilinear motion, and means like a car, wherever the car is moving on the road is a rectilinear motion because of it is moving along a straight line. And as well as a train also moving along a straight line like that. When a body is moving along a straight line in any one coordinate axis, if the body is freely falling certain height from that is also moving along a straight line. Like that, if any body is moving along a straight line is called as a rectilinear, and at the same time it's any coordinate, maybe x axis or along the y axis or along the z axis, any one axis, then that is called as a one-dimensional motion. If the body is moving in a curved path, means specifying comparing means whenever the position can be say between the according to the two coordinate axis. That position can be examined with the two coordinates, specified by the two coordinates. Then if the body is said as that is moving in a plane, so all curved paths which are moving, then that is called as a two-dimensional motion. If any object moves in such a way that it covers two directions simultaneously, its motion is known as a two-dimensional motion. Like all the motions which are having the curved paths means if in case of general example for that, if in case of a wall clock is bit on the wall, if you want to say the position of the wall clock, then we can consider that from that the vertical corner and the horizontal corner which is having in the room, means if this is considered as a room, then if we put the wall clock in this place, then if you want to say the position of the clock, then we can say from this also and from this also, and this corner and this corner. This is considered as y axis and this is considered as x axis. So that's why according to the x and y axis we can say the position of that wall clock. Like that, if in case of the lizard on the wall, then if we want to say that whenever that is on the means here the position which can be specified by using the two coordinate axis is called as a two-dimensional motion. If the path is in motion, means if the body is in motion. Here is also if the body is in motion, if any body is in motion between the two axes, means that position can be specified by the two coordinate axis is called as a two-dimensional motion. All curved paths which is moving in the plane can be considered as a two-dimensional motion. If the third one is a three-dimensional motion, if the flying kite, if the position of an object which is moving, it can be specified by the three coordinate axis. Which can be specified by three coordinate axis can be specified that, then it is said to be that is means flying kite in the air, and as well as when the fly is in the room. If we was stand in the room, this is the piece of chalk. To specify the position of the chalk, we should consider the three coordinates. Means it is the x axis, y axis, z axis. According to the y axis, z axis, x axis, so we can specify this position of the object. Means this is in the three-dimensional, which can be specified by according to the x axis, according to y axis, and according to z axis also. So that's why we can say that if the fly is on the room, then if you want to specify the position of or movement of that fly, then we can see according to the x axis we can say, according to the y axis, according to the z axis. These are the three types of dimensional motions, that is 1D, 2D and 3-dimensional motions. According to the if the specify the position, if the body is moving along a straight line, to specify the position of any one coordinate axis, we can specify the position of an object whenever it is in motion. If we specify by using the one-to-one coordinate axis, then that will be the one-dimensional motion. If in case of the position of an object can be specified by the two coordinate axis. When it is in the plane, then that will be the two-dimensional motion. If we can specify the position of an object by using three coordinates, then three coordinate axis, then that will be the body will be in a three-dimensional motion. These are the three types of, according to the way of the body, motion of the body, then we can say that one-dimensional, two-dimensional, and three-dimensional. Now in this motion in a straight line, we are going to discuss only about that motion in one-dimensional motion, that is in case of a body is moving vertically or horizontally. When the body is in motion, then what are the parameters are involved in the during its motion? Means according to that, if the body is traveled from one place to the other place, it can say that it moves some distance and it displaces from this place to the other place. And also while this body is moving, and it consists of some of the speed, means the velocity. And whenever if the increasing speed, it is called as acceleration. If in case of by the decreasing velocity, is called retardation or deceleration. These type of parameters are involved when the body is in motion. Let us see what are the parameters are involved during the motion of an object along a straight line. In the parameters, motion of parameters, now we are going to discuss about distance and displacement. When the body moves, travels from one point to the other point, it is said to be that the body is traveled some distance. Means here, what is meant by the first of all, what is distance? We are going to see first of all distance and displacement in the parameters of motion. Distance, displacement. So, in the distance and displacement, what is the distance means? When the body is traveled from one point to the other point, means when the body is traveled from one point to the other point along a straight line, either along a straight line or maybe the different path, from A to B. Body traveled from a different path. Then the actual length of the path, the total path, means the actual length of the path traveled by or traversed by a particle, moving particle, is called a distance. For example, from body A to B traveled 25 kilometers of distance. That will be the distance of the particle. Means the total length of the path traveled by a particle is called the actual length of the path. The total actual length of the path traveled by a particle is called distance. It's called a distance. It is having only magnitude but no direction, because of it is having the different directions in the respect of path. The total length, the actual length of the path we have direct. So that's why it is having only magnitude but no direction. So that's why it's a scalar quantity. Scalar quantity means the body is a physical quantity which is having only magnitude but no direction is called a scalar quantity. In that case, here the distance is having only magnitude but no direction. So that's why distance can be called as, considered as it's a scalar quantity. It's a units. It is measured in meters, centimeters. The SI unit of the distance will be the meter, and CGS unit of the distance will be centimeter. Once again, the actual path of the actual length of the path, the actual length of the path traveled by a moving particle is called distance. It is having only magnitude, no direction. So that's why it's considered as a scalar quantity. Its units are centimeter, meter, kilometer, and in that case SI unit is the meter. And if the distance cannot be negative, if the particle is moving from one in this place to 2 meters, that cannot be minus, because of it is considered as only plus. The distance always considered as a positive only, it cannot be zero also. Whenever the body is traveled from some of the place, then it cannot be zero, and as well as it cannot be negative. If the body particle is at rest, then only we can say that the distance is zero, because of that body is not in motion. If the body is in motion, then distance cannot be zero, and that is do not decreases with that time. When the body is in motion, distance never be negative, and it is decreased, do not decrease with the time. Means when the time is going on, when the body is in motion, then always the distance is increasing positive. It cannot be negative, and also do not decrease with the time. That is about the distance. If we come for the displacement, displacement means when a body is traveling from one point to the other point by moving in some of the directions, different directions, and from the whatever the length is there, then the longest shortest path means from the initial point to the final point, we can draw the along a straight line in a specified direction. If we draw a line from the initial point to the final point, then that will be the displacement. Means the shortest path, the length of the shortest path, the shortest distance between the initial and final point of the particle in a specified direction is called displacement. And then if we traveled from one place to the, we are going to the college from our home. So whenever we are coming from our home, we will wander in some of the roads. We will there is a turn is there. That is the total length of the path will be considered as a distance. But when we draw a straight line from your home to the college, then that will be the displacement. Means the shortest distance between the initial point to the final point. Initial point to the final point is called a displacement in a specified direction. That is examples we will say. It is considered is a vector quantity because of displacement is having magnitude, and also we said that in a specified direction means the initial point to the final point. There is some of the direction is there from initial point to the final point, or final point to the initial point. There is some of the direction is there. So here you can say that the displacement can be 0, negative, and also positive also. Here we are going to see how it is possible. The vector quantity is a vector quantity because of it is having direction and magnitude. So that's why it's a vector quantity. And SI unit of the displacement is also considered as meter. It is also measured in meters, kilometers, centimeters. The CGS unit for the displacement is a centimeter, and SI unit for the SI unit is meter. And here some of the examples we are going to see how to clarify about what is the difference between the distance and the displacement. And then if the body is moving along a straight line without changing its direction, then it will be distance and displacement will be same. In case of body is moving along a straight line, means body started from A and it traveled towards the some of the direction point to the B, traveled for 3 kilometers. The shortest body is moving along a straight line, without changing its direction, then we can say that here is the 3 kilometers is the distance, and displacement is also we can draw the straight line in a specific direction from initial point to the final point is this only. So that's why we can say that this is the displacement and this is the distance. So here when the body is moving along a straight line, the displacement and distance be equal. And the displacement will be 0. Some of the times displacement will be 0 because of, here see that some of the examples. Here when the particle is traveled from A to B in a curved path, that is AB, and that is called as the total length of the curve can be considered, AB curve can be considered, that will be the distance. The straight line from A to B, from initial point to the final point, we draw the in a specific direction, that will be A to B. This will be the displacement. Always displacement will be less than the distance. Do not exceed displacement. Do not exceed the distance. Always it is less than or equal to the distance only. Next, here the A will be the curved path, the total length of the curved path A will be the distance, and the shortest distance from the initial point to the final point will be the displacement. Here the other one is a particle started from A and traveled towards the B for 3 meters, and from the B to C for 4 meters. Then here the distance will be, the traveled distance is AB plus BC be the distance, so that's why 3 meters and 4 meters totally 7 meters will be the distance, and the shortest distance which can be drawn from the initial point to the final point, this will be the displacement. Displacement. It's the shortest path drawn from the initial point to point may be the shortest path, so that's why it is called as a specified direction. Okay, specified direction we draw the line, so that is called displacement, that is AC. AC be the displacement, that is 5 meters. By doing the Pythagoras method, then we can get that line 5 meters. Then the third, the displacement never exceed distance. Already we said that the displacement never exceed the distance. Okay, next, when the particle is moving from the arc of a circle, this is the arc. When it is traveled, then arc that is P to Q, which is of circle of radius r. Then its distance will be thus. It is making subtended angle theta from the initial point to the final point into the center. Is the theta be the angle which is subtended angle. Then whenever it is traveled, the total distance will be r into theta. R into theta. Distance will be r into theta. So here it is r into theta. The next, when the displacement which is taken the shortest path drawn from the point, the initial point to the final point in a specified direction, then it is said that the displacement will be 2r sin theta by 2. R sin theta by 2. We will get that from this points. We will get this by taking this value. We can get that sin theta. That is this round. We can get that 2r sin theta by 2. Here is that we are going to see some of the important points about the distance and the displacements. Displacement can be 0 when the particle has started from initial point and traveled toward some of the distance and came to the same point and returned to the same point. Then displacement will be 0. Like if the point started from A, if the particle started from A and traveled like this in all the distances and came to same position, then the total path, the path can be considered as distance, and displacement will be 0. Distance will be something, some of the part in case of travel distance is considered as 10 meters, then distance will be 10 meters, then displacement will be 0. Wherever the body or particle travels, started from the initial point and returned to the initial point after traveling some of the distance, then displacement will be 0 and distance will be some of the distance, total length of the path which has traveled. That is generally we can say that a particle can travel some distance without displacement. This is the displacement and this will be the sum of the distance. So that the displacement can be less than the distance and time comes for the curved motion. So the displacement can less than the distance because of whenever the body travels in some distance, always displacement is less than the distance, or when the body is moving along a straight line, then only displacement which is equal to distance for straight line motion, and displacement is less than for distance for a curved motion. Whenever it is moving a curve, this will be the distance and this is the displacement which is less than the distance. Here is the, so we can say that again the particle moves whenever the displacement never exceeds the distance. Displacement will never exceed the distance. Here is that whenever the displacement can be 0, can negative, and can be positive also. Displacement can be positive, negative, or 0. From here, whenever the body is reached to the same, return to the same point, then will be 0. Whenever the body is traveled and returned from the same path, retraced from the same path, then we can say that whenever the direction of opposite, then this displacement can be negative. We will calculate the negative. Then positive means whenever the body is traveling along some of the straight line, we can say that displacement will be positive. This is about one of the parameters of motion, that is distance and displacement.